Hello everyone, my name is Marcus Kander. I'll be explaining today how to solve rotational motion questions that involve calculating velocity for horizontally spinning objects. For this question, you're asked to calculate the velocity that a car must drive at in order to safely make it around a 38-meter radius turn that is banked at 25 degrees. You're told that the surface is frictionless. The first step to solving this question is to draw a free body diagram. There are two forces acting on this car. First, there is Fn, the normal force, which acts perpendicular to the surface. Since the surface is on an incline, you have to break Fn into its x and y components. Second, there is Fg, the force of gravity, which acts straight downwards. The second step to solving this question is to set up a net force equation in the x and y direction. In the y direction, the equation should look like this. Fg and F and y are equal because the car does not move upwards or downwards. F and y is equal to Fn cos theta, which we know by simply looking at the free body diagram. After setting up the equation, rearrange it to isolate for Fn. Fn will become useful when you're setting up the net force equation in the x direction. In the x direction, the equation should look like this. Fnx is the force providing the centripetal force. No other force is acting in the x direction because the question tells you the surface is frictionless. Fnx is equal to Fn sine theta, which we know by simply looking at the free body diagram. To simplify this equation, substitute Fn into your x direction equation. If you look here, you'll find that we have sine theta divided by cos theta, which simplifies to tan theta. After doing this, isolate for v by multiplying by the radius, cancelling out the masses, and square rooting the equation. Your final equation should be the square root of gr tan theta. Now, all you have to do is plug in the missing values, which should give you v equal 13.2 meters per second. That's it for this video. Thank you so much for watching. If you have any questions or want me to clarify anything, please leave me a message in the comments and I'll respond to you as soon as possible.